Assalamualaikum warahmatullahi wabarakatuh. My name is Miftahurrahman Akbar Hanafi. I'm from Mathematical Education in Universitas Negeri Jakarta. Today we gonna talk about L'Hopital rule. What is L'Hopital rule? L'Hopital rule is a general method of evaluating indeterminate forms such as 0 over 0 or infinite over infinite. To evaluate these limits of indeterminate forms for the derivative in calculus, L'Hopital rule is used. L'Hopital rule can be applied more than once. You can apply this rule, still it holds any indefinite forms every time after its applications. If the problem is out of indeterminate forms, you can't be able to apply L'Hopital rule. Consider that limit x as approaches 2, x squared minus 4 over x minus 2, or limit x as approaches 1, ln x over x minus 1. If we try to evaluate by direct substitution, we get 0 over 0. 0 divided by 0 cannot be evaluated. The limit may or may not exist and is called an indeterminate form. In the case of the first limit, we can evaluate it by factoring and cancelling. Limit x as approaches 2, x squared minus 4 over x minus 2 equals to limit x as approaches 2, x plus 2 times x minus 2 over x minus 2. Cancel both and we get limit x as approaches 2, x plus 2 equals to 4. This method does not work in the case of second limit. L'Hopital's rule. Suppose that f and g are differentiable and derivative of gx is not equals to 0 near a, except possible at a. Suppose that limit x as approaches a, fx equals to 0, and limit x as approaches a, gx equals to 0, or that limit x as approaches a, fx equals to plus infinity or minus infinity, and limit x as approaches a, gx equals to plus infinity or minus infinity. In other words, we have an indeterminate form of type 0 over 0 or infinite over infinite. Then limit x as approaches a, fx over gx equals to limit x as approaches a, the derivative of fx over the derivative of gx. If the limit on the right side exists or is infinite or negative infinite, note that the rule is also valid for one-sided limit and for limits at infinity or negative infinity. That is, x as approaches a can be replaced by any of the symbol x as approaches a negative or x as approaches a positive or x as approaches infinite, positive infinite, and x as approaches negative infinite. For example, we have limit x as approaches a fx over gx equals to limit x as approaches 2 x squared minus 4 over x minus 2. Limit x as approaches 2 the derivative of x squared minus 4 over the derivative of x minus 2. We get limit x as approaches 2, 2x over 1 equals to 4. Another example, limit x as approaches 1 ln x over x minus 1 we get limit x approaches 1, the derivative of ln x over the derivative of x minus 1. The derivative of ln x, which is 1 over x, we get limit x as approaches 1, 1 over x over 1, or limit x as approaches 1, 1 over x, we get 1. The next example is limit x as approaches infinity e to the power of x over x. We get limit x to the power, limit x as approaches infinity, the derivative of e to the power of x over x, or limit x as approaches infinity, e to the power of x over 1, we get infinity. The next is indeterminate products. For example, limit x as approaches infinity, x sin 1 over x. This approaches because infinite times 0. We write as a ratio. We get limit x as approaches infinity sin 1 over x over 1 over x. This also approaches 0 over 0. We already know that limit x as approaches 0 sin x over x is 1. But if we want to use L'Hopital's rule, limit x as approaches infinity sin 1 over x over 1 over x, we get limit x as approaches infinity cos 1 over x times minus 1 over x squared over 1 minus over minus 1 over x squared. We get limit x over limit x over infinity cos 1 over x equals cos 0 equals to 1. For the indeterminate difference, we get limit x as approaches 1, 1 over ln x minus 1 per minus 1 over x minus 1. This is indeterminate form, which is infinity minus infinity. Then we rewrite this as a ratio. If we find a common denominator and subtract, we get limit x as approaches 1, x minus 1 minus ln x over x minus 1 ln x. Now it is in the form 0 over 0. Then we get limit x of x as approaches 1, 1 minus 1 over x over x minus 1 over x plus ln x. This is when L'Hopital rule applied to launch. And then limit x as approaches 1, x minus 1 over x minus 1 plus x ln x. The fractions are clear, but still it's 0 over 0. Then limit x as approaches 1, 1 over 1 plus 1 plus ln x, L'Hopital again. The answer is 1 over 2. Indeterminate powers. Indeterminate, the form is 1 to the power of infinity, or 0 to the power of 0, or infinity to the power of 0. Evaluating these forms requires a mathematical trick to change the expressions into ratio. For example, we have ln u to the power of n equals to n ln u equals to n u ln u over 1 over n. We can then write the expression as a ratio, which allow us to use L'Hopital's rule. Limit x as approaches a fx equals to e to the power of ln limit x to the power limit x as approaches a fx. We can take the log of the function as long as we can exponentiate at the same time. We get e to the power of limit x as approaches a ln fx. Then move the limit notation outside of the log. Limit x as approaches infinity x to the power of 1 over x, we get infinite to the power of 0. E to the power of limit x as approaches infinity ln x to the power of 1 over x, then e to the power of limit x as approaches infinity 1 over x ln x. We get e to the power of limit x as approaches infinity ln x over x, which means we have infinity over infinity, and then e to the power of limit x as approaches infinity 1 over x over 1, which we have L'Hopital applied. And then the answer is e to the power of 0, which is 1. Thanks for watching.